Earth was not shaped by calm weather or predictable seasons. It was shaped by violent eruptions, sudden cooling events, rapid warming pulses, and atmosphere-altering impacts. The stability of recent centuries is the exception, not the rule. When the forces that drove earlier transitions begin to move again, the planet follows. A primal Earth is not imagination. It is the natural state this world has entered many times. Several of those forces are active now. They operate beneath the crust, inside the oceans, throughout the atmosphere, and within the magnetic field. When even two of them shift at the same time, the climate can reorganize faster than modern society can respond. Volcanic activity is one of the strongest triggers. Minor eruptions in recorded history have cooled the planet enough to disrupt crops across continents. Tambora in 1815 caused global temperature drops. Pinatubo in 1991 lowered temperatures and altered weather for years. Those events were small compared to ancient supervolcano eruptions. When a caldera-scale eruption pushes ash and sulfur into the stratosphere, sunlight drops and temperatures fall quickly. Jet streams drift away from their normal paths. Storms intensify as the atmosphere responds to the sudden energy imbalance. A sustained volcanic winter would bring sharp cold waves, failed growing seasons, and a sky filtered through particles that block a significant amount of sunlight. Volcanism can flip the system in the opposite direction as well. Basalt flood events have released massive volumes of lava and greenhouse gases that transformed Earth into a hotter and storm-filled world. The Siberian Traps event pushed ocean temperatures upward, weakened oxygen levels, and amplified rainfall extremes. A smaller-scale version today would still drive powerful monsoon shifts, severe drought cycles, and intense seasonal storms. These processes are confirmed in the geological record. They do not belong to fiction. Impact events add another pathway to rapid change. A large asteroid strike injects dust, soot, and vapor into the stratosphere. Sunlight falls sharply, creating immediate cooling. The Chicxulub event shows how violent the aftermath can be. The world shifted into a state of atmospheric shock. Storm systems reorganized as temperatures fluctuated. Even an impact far smaller than Chicxulub can alter climate for years. These effects are based on direct observations of past events. Ocean circulation acts as a global thermostat. The Atlantic overturning circulation moves warm and cold water between hemispheres. Geological evidence from the Younger Dryas proves how quickly this system can collapse. Once it weakened, Europe plunged into intense cold, while other regions warmed. Storm tracks shifted within a few years. Modern measurements show early signs of stress in this system. If the circulation crosses a threshold, global climate patterns would change abruptly. Earth's magnetic field contributes another layer of instability. It has reversed polarity many times. During a reversal, the field weakens, allowing more cosmic radiation into the upper atmosphere. Ionization increases. Lightning activity can rise. Atmospheric chemistry shifts. Auroras expand into latitudes where they do not normally appear. A weakened field also makes the atmosphere more sensitive to strong solar storms. None of this flips continents or moves oceans, but the electrical environment of the planet becomes far more active. True polar wander operates on longer timescales. Internal mass shifts inside the planet cause the crust and mantle to adjust relative to the rotational axis. This does not produce sudden geographic changes, but the intervals when it occurred align with periods of intense volcanic output and strong mantle plume activity. These internal adjustments stress the crust and increase eruption rates over extended periods. The environment that follows is harsher and far more geologically active. These systems interact. When volcanic aerosols alter jet stream behavior during a period of rapid ocean warming, the atmosphere becomes unstable. When a weakened magnetic field coincides with heightened solar activity, electrical disturbances increase. When circulation shifts overlap with strong volcanic forcing, climate reorganizes rapidly. Earth responds to combined stress, not isolated events. That is why past transitions were abrupt and severe. The world people recognize today depends on the temporary alignment of ocean stability, magnetic strength, atmospheric structure, and volcanic quiet. Those factors do not remain fixed. The geological record is clear. Earth has returned to extreme states many times. It will do so again when the right forces converge. A primal Earth is not a new world. It is the planet returning to the conditions that shaped its deepest history.